Hello, Marauders. I've snuck into Disneyland this week, so that's where I'm hiding now. This week we're going to do vectors. We're going to do section 6.6 and 6.7. There's no school Friday. In fact, it's a 4-day weekend, so the test is Thursday, but you can do it Friday if you like. So you can do it Thursday or Friday this week. Okay, so let's learn about vectors. A big part in real life, a big part in physics. If you're studying to be a pilot, when I was doing my pilot training, we had lots and lots of vectors. Okay, so let's check it out. Okay, so here's the plan this week. We're only going to spend 1 day on each section, Wednesday review, and then here's the test. So we're going to have to squeeze it down a little bit. Okay, so this is vectors, and we're going to learn what is a vector. You could read the book, it explains it pretty good. I'm going to look at this direction sign. This is what vectors are. A vector is two things. It's like these little things. A vector tells you which direction to go and how far to go. So if you wanted to go to these different places, you just follow the direction of the arrow and go that many miles. So that's what a vector is. It tells you a direction and a distance. And that distance we called a magnitude. Okay, so two types of numbers. Some numbers are just called a scalar, which is just a plain number. What do you mean a plain number? Like if I said $10, is there a direction? No, there's no direction. It's just an amount. Or I could say the temperature is 75 degrees Fahrenheit. There's no direction. It's just an amount. Okay, or I could say 5 feet. That's got an amount, a magnitude, but no direction. But some numbers, in addition to the amount that you can measure, that's the magnitude. This is like the power, the force, the distance, the amount. A vector has magnitude, but it also has directions. For example, here's some vectors. Move 100 pounds up a 30-degree ramp. So it tells you how much and what direction. Run 10 miles, that's how much. We call it the magnitude. East, that's a direction. Fly 200 miles, that's the magnitude, how much, at north 10 degrees west. Remember our polar coordinates? 3, 45 degrees. Remember, this was the radius, this was the angle, this was the length, or the distance, and this was the direction. So vectors are kind of like polar coordinates. Okay, here's a vector. Let's say you started at A, and you're going to go to B. Where's B? Let's see, I can go any direction. Maybe I'll go this way. And the farther you make it, well, the farther you go. So maybe I'm going to go this way to point B. Notice we have a start and an end. So when I draw a vector, it looks like a ray from geometry. Remember you'd say like ray AB? Well, it's the same with vectors. I could just say it's vector AB. It starts at A, goes to B. This is the direction. I could use my unit circle to figure out which way it's going, or I could use a protractor, or see which way. And the longer I make it, the farther it's going. Sometimes we give it a name, like say, hey, let's call this, instead of calling it vector AB, sometimes we use a letter like, hey, let's just call it V. We'll call it vector V. Okay, so here's some in the book. We've got P and Q. So this is the initial point. In other words, like initiation, the start, and terminal is the end. I've reached the terminal, or terminal is the final thing. That patient is terminal. A P to Q, from P to Q. So they write it as PQ. What's this here? These kind of look like absolute value bars. Sometimes they say, could you just tell me the length? We'll talk about that in a moment. Here's some vectors. These vectors are equal, because you notice for vectors to be equal, like they just call, let's just call this V and call it W. If V equals W, they have to have the same magnitude and same direction. The magnitude, do they have the same length? Yes. Do they go the same direction? Yes. These ones, they're not going in the same direction, like we're walking off in different directions. These look the same, but wait a minute. V is going downward, W is going upward. We're going opposite direction, so we're not equal. And here, well, W went farther than V, they're not equal. So they have to have the same magnitude and same direction. If you looked at these two vectors, are they equal? Well, yeah, it looks like they're the same direction. Hey, we could check the slope. Up 1, 2, 3, 4, 5, 6 over 3. Same with this one, up 6 over 3. So they do have the same direction and same magnitude. So here's how you can actually write that vector. So remember I said this vector, it starts here, there's 0, it went up 6 and over 3. This is how you write it. You're going to say, okay, so here's how we write. This is the format that they use. Often they use the letter V. Okay, there's a horizontal move and a vertical move. Now the vector I just looked at, we'll call it vector V, or we could use vector U. It went up 6 and over 3. And let's just call this vector V. So the way you're going to write it is this. You're going to say how much it moves horizontally first. That's going to be A. This is A. Horizontally is over. So kind of like backwards from slope, you're going to do the over first. You're going to say 3, and you're going to put the letter I. These are the letters they liked. It's not imaginary. They just decided to call the horizontal part the I direction. Like if you had graph paper, they decided to call this the I direction. And the other part is the J direction. So this one went up 6. This is B. I know it's kind of weird, there's 2 letters. You're going to put 6, J. So you always put I and J for I and J on the graph paper. So you're going to say, well, it went 3 in the I direction, which is the horizontal, and it went 6 in the up and down direction, the vertical. And so this is how you write the vector. Okay, let's try another one. Look at this vector. It goes from here to here. They wrote negative 3i plus 4j. I know they have x and y here, but you think of these as I and j, like in the alphabet, H, I, J, K. So this one goes negative 3i, it went back 3, so the negative, and then up 4. Okay, so there it is. If I said, let's look at this vector. It goes back 5, up 6. What about this vector, P? Well, let's see. I'm going to write this vector. I could say, well, it goes back 1, 2, 3, 4, 5. So I'm going to give it a name. I'll just call it vector. How about I call it vector U for a change? It's going to go back 1, 2, 3, 4, 5. And it goes up 1, 2, 3, oops, right here. 1, 2, 3, 4, 5, 6. So there you go, negative 5i plus 6j. So let's go back to this vector. Whether I pick U or V, they actually look the same. So I'll just pick vector V. They like to call the vectors U and V, their favorite letters. So this, we said this was up 6 over 3. So which one do we do first? 3i plus 6j. Remember, it's horizontal, this way, and then vertical, up and down. But sometimes they say, how long is it? Okay, so it went over 3, up 6. How far did it go? Well, isn't that like the Pythagorean theorem? How far did it go? If it went 3 this way and 6 this way, isn't that the Pythagorean theorem? It is. And here's how they're going to say that. They're going to say, instead of saying, tell me the length, or tell me the hypotenuse, or tell me the radius, they're going to say, tell me the magnitude of this vector. So remember, magnitude is just a fancy way to say the distance or the power. And so we're just going to do Pythagorean theorem. You're going to take these guys and go 3 squared plus 6 squared, and take the square root, do a little math there. Over here, they do it with the distance formula, which is really the Pythagorean theorem. But here's your 3 squared and 6 squared, 936, square root of 45. And they put 3 radical 5. They broke down the radical. You could also put it as a decimal. So 45. Remember the thing, you go like this. 9 times 5 is 45. I know that guy. 3 root 5. So that's the magnitude. And when they write that, they're going to go like this. They're going to say, they're going to take this problem, 3i plus 6j. They're going to put these double bars. That's the symbol they use for magnitude. Here's a few other vectors. You can see this vector is twice as long. This one's half as long. This one, negative, they went the opposite direction. It's 1.5 times as long as the original. Okay, so here's a couple vectors, u and v. That's the letters they like to choose, remember? And if I say, okay, we have 2 vectors, here's some other things we can do. Oh, well, here's the one we just did. Remember, they say, what's the magnitude of u? Go ahead, figure it out. How long is this vector? You could pause the video to figure it out. Okay, if you figure it out, you could draw it. Let me see. Horizontal is 5. 1, 2, 3, 4, 5. And vertical is 2. 1, 2. I don't need graph paper. I'll just draw it in like that. So this is my vector, like that. And so remember, when 5 this way, 2 that way? Oh yeah, it's Pythagorean theorem. Remember, this is how they write it. What's the magnitude? They put these double bars. Kind of like absolute value, how far from 0. So I just did 5 squared plus 2 squared, radical 29. I could change it to a decimal, and sometimes we just leave it. I could also do v. And of course, the negative doesn't really matter because the magnitude is a distance. So when you square the negative, I didn't draw it there because it would just get wiped out anyway. Radical 25, 5. In fact, 3, 4, 5. Okay, here's something else you can do. You can, okay, they might ask you to add the vectors or subtract the vectors or even do something fancy. Okay, so with the vector, let me, before we even add them, sometimes they'll say, hey, what is 10u? 10u? That means, what's 10 of these together? If you say, well, do you have to go like u, 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 u? You could draw them all out and just keep going. Or how about, if it says 10u, just multiply it by 10. Just go, okay, what's 10 times 5? 50. 10 times 2? 20. This would be a new vector, 50i plus 20. That's just 10 times as long. What if I said add these 2 vectors together? Could you add the vectors together? Yeah, you can. There's 2 ways to do it. Once again, you could manually draw it out, and this is what something that pilots would do on their maps. They would just draw it out. They'd say, okay, I'm going to fly my plane 1, 2, 3, 4, 5, and then up 2. I would go here. I'll do him in this green color. And then after that, I'm going to fly -3 plus 4. I'm going to go back 3, 1, 2, 3, then up 4, 1, 2, 3, 4. And then that would be this vector. And they say, where did I end up? So if I flew vector u, then vector v, and I did u plus v, I'd go, okay, I'm going to go over 5 up 2. But then when I go back 3 up 4, my result is this. This is where I'm at. So I could have just went like that. It's kind of like, remember the thing where we flew, where we had the boat and then the wind blew us off course, or the current? So if I flew this way, or maybe the wind blew me was that way, this is where I'd end up. Well, what is this vector here? Well, we call this vector w. How do you do that vector? Well, if I had graph paper, I could count it out. Or here's an easier way. Check how easy this is. Just add the vectors. You could just say u plus v. Just add these up. Just go, okay, we'll call it vector w for short. 5 plus -3, 5 take away 3 is 2. 2 and 4 is 6. And this is your vector. Super easy to add vectors. Just add up the horizontals, add up the verticals. You could draw it out and then try to count on graph paper. Pilots actually do it this way. They actually draw it out on the map. Because what if there was like a big mountain here and they want to crash the mountain? They might actually say, I'm going to fly this way, then this way to go around the mountain. But here's where I ended up. Could you do, how about v minus u? Yeah, make sure you get the correct order. V minus u, start with this guy, -3i plus 4j, and then subtract u. U is 5 10I plus 2j. So the order matters. You're going to have this subtract that. Remember, a long time ago, distribute the negative, the evil negative. -3, subtract you, take away 5. -3 minus 5 is -8. And then now, 4j subtract 2j. So v subtract u. 4 minus 2 is 2. And this is your new vector. Okay, so you can do all types of stuff. Here's a challenge. Could you do 2u minus 2v? Let me give you a chance. 2 times this, double that. 2 times this, double that. Then subtract. See what you get. See if you can get this right. Pause the video. Okay, here's the answer. Make sure you try it. Don't just look. I got 16i minus 4j. Am I right? Let's see. Here's how I did it. I doubled this guy, 10i plus 4j, and then it says to subtract. Make sure you're doing the u first. Now it's v. Double this guy, minus 6, double that, 8j. Make sure your i's look different than your j's, and your u's look different than your v's. So now I have, putting this together, I got 10 minus a minus, that's actually plus, 10 plus 6, 16i. And then I have 4 minus 8, 4 minus 8 is -4. So that's your resulting vector. Otherwise, you'd have to draw like u, and then subtract 2v. How do you subtract 2v? Instead of going what you would normally go, like -3 up 4, you do it in the backward direction. You do it in the opposite direction. You would do +3 down 4, and you would do 2 of those. And this is where you end up, which looks kind of correct, over 16 down 4. The book has lots of examples, like here's v. What's 6v? Okay, 6 of those and 6 of those. That's just multiplying it. They call it a scalar because 6 is just a plain number. 6 times each one of these, just jump to here, 30 and 24. 6 times those. What's -3 of these? Times it by -3, so -15, -12. Times it by -3. They get a little fancier, like we just did. Here's some v's, here's some w's. What's 4 v's minus 2 w's? Make this 4 times as big, right there. Make this -2 times them by -2, right in there. They got in here, and just add it all up. You can look through the example on your own. Some people just do it in their head. 4 of these, 20, subtract 12, 20 subtract 12, 8, and then just keep going from there. There's a bunch of properties, nothing fancy. Zero vector means don't move at all, just you go nowhere. And now there's something called the unit vector. The unit vector, remember the unit circle? And it's got this funny little rule here. Here's what a unit vector is. Okay, for unit vector, right here, let's go back to vector u, over 5 up 2. Here's vector u. And if I said, how long is vector u? Remember we go like this? You have these double bars. How long is vector u? And you did a little Pythagorean theorem. You did 5 squared plus 2 squared. That's 25 plus 4. Okay, the distance here is radical 29. But what if I said, I would like you to make a unit vector? A unit vector, yes, a unit vector. A unit vector is a vector with length of 1. In other words, you're trying to fit it on the unit circle. Imagine you had the unit circle and you were like this, so like 1, or like polar graph paper. 1, 2, 3, okay, 4, 5. Or like 1, 2, 3, 4, 5. Because this was over 5. What if I said I want the vector to only go just a little bit, just right there, just a tiny, tiny bit. And I don't know if I could highlight that, but if you just want the vector to go a distance of 1, what vector is that? Okay, so here's the rule, how it works. It sounds a little complicated, don't worry. To get the unit vector, you're just going to write your vector over the magnitude of the vector. Okay, so in other words, just take your problem, 5i plus 2j, right? Just write the problem again and divide it, put it over whatever the distance was. Radical 29. But you're not done. You have to split it into 2 parts. So in other words, you're going to separate this, and you're going to write your final answer as 5 over radical 29i plus 2 over radical 29j. This is the unit vector, okay? Unit vector. So this vector just goes over this little fraction and this little fraction. It's still the same amount, isn't it? It's just divided that much shorter. So here it is again, unit vector. Take the vector, put it over that, split it, you're done. Okay, you write the unit vector for this one. Go ahead and try it. Remember the rule, you get the unit vector, you're going to put whatever the vector is over this. So what is this? That's magnitude. Okay, what is your answer? Go ahead and pause it, then come back. Okay, so the unit vector, take the vector, write it, negative 3i plus 4j. What are you going to divide it by? What was the distance of this guy? What was his magnitude? I did it earlier, Pythagorean theorem. 5, in fact, it's a 3, 4, 5. You're just going to put it over 5. Oh, but you can't leave the answer. You have to write it like a vector. You got to have the horizontal and vertical. So just split it. Call it negative 3/5 I plus 4/5 j. That's the unit vector. All right, we're nearing the end here. Going quick. What if I said a vector had a magnitude of 50 miles per hour at a direction 100 degrees? How do you write that vector? And if you're like, okay, maybe I travel 50 miles per hour at this direction. How much did I go over? How much did I go up? And you say, well, can I draw this vector? And you say, write it as a vector. You could say, okay, let's see, I start here. 100 degrees, let's see. Think of my unit circle, zeros over here. Let me bring this up. So pretend like, okay, imagine unit circle, 0 degrees is here, here's 90. Okay, 100 degrees is this way. And then, I don't know, I'll say about there, and I'll say we'll go 50 miles, right? Maybe I go in 1 hour, 50 miles per hour. But what vector is this? How much did you go over and how much up? And you're like, well, I'm not sure. I went that direction. Like, here's my unit circle. I went 100 degrees. There's 100 degrees. I went this way at 50 miles per hour. Maybe the wind is blowing that way. You've seen those weather maps, and they're showing like the wind's going this way. I don't know if you ever noticed, the longer they draw the arrows, the stronger the wind. If they draw a little arrow, that's a short, like a weak wind. This is a big wind. So how much is this over, and how much is this up? Well, trigonometry. Remember, if this is 50, if I want to find the x part, don't I use the cosine? And don't get scared. And if I want to get the y part, don't I use the sine? Oh yeah, opposite over that, adjacent over that. Well, they summarize this into a nice, easy rule to help you not get a little too lost. It's right here. You're going to write the distance of the vector, cosine, sine. Okay, we'll try it out. Okay, don't worry, it's not that hard to do. We're going to use the rule. The rule says, okay, to write it, you're going to do the magnitude, okay, then times the cosine of the angle with an I plus sine. Whoops. I gotta write this in again here. And then the magnitude sine of the angle with the vector. I'm going to do that. Okay, so here's the rule. Sorry, it was kind of messy. I don't even have to draw the vector. You're just going to put the magnitude. Guess what? It's already right there, 50. So you're just going to write 50 cosine. There's the angle, 100 degrees, and put I. Then do it again. Write the magnitude, 50, sine of the angle, 100 degrees, J. You might think, oh, cool, but wait a minute. What are we going to do now? We're going to change it. This is what I got so far, 50 cosine and sine. Then what you're going to do is kind of use your calculator. What is these numbers? So you would punch this in your calculator. So don't get scared of this rule. It's pretty simple. You're just going to go 50 times the cosine of that for the x, because remember, this gives you the x. And then you can do 50 times the sine, which is the y. So in fact, right now, it's really what we were using before. Remember this? R cosine theta. X is R cosine theta. Isn't that this? R cosine theta. Isn't the magnitude the radius? And y was R sine theta. Isn't the magnitude really just R? Isn't this really just say R sine theta? It's the same thing. These are your x's and y's. So what is cosine of 100? I hit cosine of 100. I'm in degrees. And I got negative 0.17. Okay, so this is negative 0.17. And I got to times it by 50. I'm not going to round it off yet. I'm going to multiply it before you round it off. Negative 8.6. So this part is negative 8. I'm going to round it off now that I'm finished. I plus, okay, and the other one, sine of 100. Okay, I got that. Don't round it off yet because you got to times it by 50. Keep it in your calculator, times it by 50. Now you can do some rounding. 49.2. 49.2j. This is your vector. Okay, so that's how you do it. Let's look at one more. So lots of stuff. Don't worry, we're almost done. They say, okay, the wind is blowing at 20 miles per hour in the direction north, 30 west. Okay, so they do it this way. It's going this way 20 and north 30 west. Okay, so it might have been a while since that. Here's north and a little bit to the west. So let's figure out this angle. Well, this is unit circle 90 plus 30 more. That's a 120-degree angle. So here's your rule, right in here. So you just write the magnitude. Got it. 20. Cosine, this angle was 120, but nice if they just wrote it normal. And then once again, magnitude, sine. It's just the x and the y. Put that in your calculator. In fact, this one, they just peeked at the unit circles. They go 120. You got that already. I got that right here. They looked them up on here. Did 20 times the cosine. Right there, negative a half, negative 10. 20 times the sine. You could use your calculator. They looked it up, so they got the radicals here. Did a little canceling, 10 radical 3. If you did in your calculator, you might have a decimal here. But there's your vector. Okay, this last part is the physics thing. Say Mo pulls a rope attached to a box with 100 pounds of force. Jane pulls the opposite direction, 100 pounds of force. How much does a box move? So if here's a box, and one person's over here, and one person's over here, and he pulls this way with 100 pounds, and she pulls that way with 100 pounds, it cancels out, doesn't it? What if she pulled with 110 pounds? Well, it's going to move, she's going to win, isn't it? In fact, overall, 110 take off 100, she's going to win with 10 pounds of force. It's going to start nudging this way with 10 pounds of force. But what if they pulled at an angle? This is if you could get super low. Don't you think it'd be more like if they're right here and there was a box, wouldn't he be pulling at kind of an angle and she's pulling at an angle? And now, what if he gets too close and he's pulling more upward? Then the box actually lift off the ground. Could you add these vectors together and actually figure out where the box moves? Okay, so this would lead to AP Physics, and they spend a lot of time trying to learn this. And I'm not expecting you guys to learn this suddenly at this quick little lecture. This would take a whole other day, but I will show you some AP Physics. If you can do this, you're ready for AP Physics test. Let's say somebody, this is just a little example from the homework. I'm just going to throw it out here. Say a force 1 pulled with 70 pounds of force at this angle, and force 2 pulled with 50 pounds of force at this angle. What's the resultant force? Well, how much did the item move? And you can't say, well, 120 pounds of force. What if they're in opposite directions? The only way to add these together, or they could be pushed in the same sort of way. You can't, it's going to be a weird answer. So what you have to do is change these into this, into the kind of trigonometry style of the vector. You have to put 70 cosine of the angle, 70 of that, multiply it, and now you got it written as a normal vector. And you change the other guy. 50 times his cosine, 50 times this sine, you got this vector. Now that you got it written as vectors, you can add them up. You could go, okay, I'm going to add these numbers, and I'll add these numbers, and I'll have the vector. See, that's why you want to know this. That's what people have to do in real life when they're calculating out these forces. Any engineer is doing that. So we add these together, and we got, now it's going to go this much in the horizontal and this much in the J. There's like, hey, could you change it back to the magnitude and the angle? And you're like, okay, let's see, how would I do that? Oh, Pythagorean theorem to give me the total pounds. So I did a little Pythagorean theorem on it. And what's the direction? I did a little tangent. I could draw it out here. I said, okay, that's the y, that's the x. The tangent's the opposite over the height adjacent. There's the angle, negative 12 degrees. And I kind of go, well, where's that? Okay, so we're 108 pounds this way, negative 12. And I did it in this southeast thing. You could have just said it's negative 12, or you could subtract from 360 and say 300 and some degrees. And same with 67, it's another AP physics question. And the pilot has to do it. So if you want to try it, you can, but I'm not expecting you to be able to do it. Okay, so you get to try the homework. I know it's kind of a lot here, but we're so smart. This is what I was going to have you do, but do every other odd. So do 1, skip 3, do 5, skip 7, do 9, skip 11. That way you can get it done quicker. Have fun to get credit. Submit a photo of your work. If you can't, type in the answers. And I know it's all right up here, but have fun. Look at the book. It explains a lot of stuff. And the next lesson will be vectors. And that's going to be the end of trigonometry. Bye, guys.